isomorphic application. I'm pretty excited about that. Also, Porch was nice enough to give us the space and provide the food and drinks, so let's give them a round of applause. I'm going to let them speak a little bit about Porch.
Thanks, Justin. Hello, everybody. It's a little awkward with this little PowerPoint. Welcome. We're really excited to have you all here, and we're stoked about React and Flux, and happy to share our experiences. A little bit of background: we've been working on React and Flux for about 6 or 7 months now. We're building all of our new features with React, and we're kind of incrementally rebuilding a lot of our existing product suite with React and Flux. One of our biggest goals was, when we first started developing React, was SEO. So obviously we wanted to solve the problem of server-side rendering, and we wanted to have a full experience for the user as soon as the page loads, and for Google and all of that. So we did a bit of research, and we obviously landed on React. We're really happy with that. And, so I'm just going to go ahead and jump into it. There's a GitHub repo. We'll come back to that. I have like 4 or 5 slides, and then we'll dive into code. So it won't be too long. But if you are interested, you can clone that down and run it yourself, or you can just watch. I'll walk through the code base. All right. So as I mentioned, we are rendering our entire application and all of our pages on the server, which is called Isomorphic JavaScript, and people are referring to it as the holy grail these days. It's kind of like the dream of the 90s is alive, where we can actually build up an entire HTML page and send it from the server. First load experience is really fast. Google's happy. It's very maintainable. There's a mantra around the JavaScript community: write once, run anywhere, and we're kind of leveraging that as much as possible. So React obviously supports isomorphic JavaScript and isomorphic applications really well, giving you the opportunity to render your components in either environment based on different APIs that they give you, render versus render to string or static markup. We'll look at that. And the Flux flow also works really well isomorphically. So whether your action that starts the flow is client-side via a user interaction or server-side in the incoming request, either way, the action creators enter into the Flux flow, and everything happens from there. So if you're not familiar, we can talk about it a little bit. The main paradigm with Flux, which is going to be the focus of this talk really, is the unidirectional flow of data. So at any one point, data is only moving in one direction, which makes building complex applications really easy. It simplifies a lot of the process and makes our lives as developers and engineers much better. No more do we have to manage all these ripple effects from a user interaction. We don't have to keep 85 different dynamic states in our head as we're building a new feature. It's really nice because at any given time, what's being rendered is just a snapshot in time. It's a moment. It's the absolute latest and most current state of your application, of your data, of the fact that this accordion is expanded or this form is half filled in. At any given time, it's a moment, it's a snapshot in time, and you can trust that. And all you have to do is analyze your current state that you're getting. Because, as you may or may not know, React re-renders the entire application on every state change. Which I'm not going to talk a lot about the internals of React. We're really going to focus on Flux and application architecture using Flux. So, diagram here is the most simplified version of Flux paradigm. It basically starts with an action. As I mentioned, it can be on the server or client side. Those actions get handled by some central dispatcher, which basically pass along any data and the fact that an event happened to a store. And then views are listening to stores, and whenever a change happens in the store, the component, the React component is updated. It hears that change and re-renders itself, and React gives you a lot of nice entry points to handle that flow. So in our case, in this isomorphic application, the first action here on the left side is going to be the initial page request to the server. We're going to look at some code, but once the server actually renders and the user starts interacting with the application, they're just generating new actions that go around the same cycle. So this diagram illustrates perfectly how React and Flux supports isomorphic applications and lets you render on the server and then pick up on the client where you left off. Action creators, wherever they may come from, just fire off actions. The dispatcher hears them. They let the store know that something's happened. The stores update their internal state and emit a change event that components are listening to. And then when the view component hears that a change happens, it handles that and it renders. So here's just a little more info. There are a couple issues to consider when you are rendering server side. Node, as you probably know, is a concurrent environment. So as you have different users using your application, you have to deal with the fact that there may be concurrency issues and you want to prevent any data from leaking between requests. Obviously, you don't want one user filling out a form and submitting a form interacting with some other user. So the first issue that you have to solve is scoping your data and scoping your entire application per request. What that means is that you need to, there's a couple different ways of handling that actually, but the way that we've handled it, and so, yeah, let's step back for a second. We're using a library called Fluxible, which gives a lot of awesome tools to help you achieve this isomorphic application. The first thing it gives you is a way to instantiate your stores per request. It gives you a global context per request, and within each context, it instantiates instances of your store. So that prevents the concurrency issue that we want to avoid. Another awesome feature that Fluxible offers is basically sharing your application state from your server to the client side. So when the initial request comes in, you need a way to handle that, gather some data, handle some server logic, and then share the state of your application with the client side. We'll look at code. Should probably just jump into that. But Fluxible is an awesome library developed by a guy named Michael Ridgway at at Yahoo. And it's basically just a pluggable application container that makes use of a few different smaller core libraries for routing, data fetching, and dispatching. So once again, here's the repo. I'll also mention that on the repository, there's a little link to a Gitter chat room. If you guys want to jump in there, I'll check back periodically or talk with it yourselves. So let's jump into some code. So I think the way I'm going to do this is we're going to basically start with the initial request, follow the request through our Flux application, pick up client side, and then demonstrate some interactivity, how a user might actually use the application. So right now I'm in server index, although I'm going to start here with app.js in source. So this is basically setting up our global application. It's creating a new instance of a Fluxible app. It's defining a root component, basically installing plugins. As I mentioned, Fluxible is a pluggable container. You can write your own plugins, which is really nice, but they've provided a few to handle some of the common problems around fetching data isomorphically, which is called fetcher, and being able to handle routing both on server side and client side, and that's called router. And an interface to basically register your stores. And again, they've abstracted a lot of the stuff, and it's all behind the scenes, but any stores that you register will be instantiated per request, and they've handled all of the scoping and concurrency issues for you, so it's pretty nice. So we set up our initial app instance here, and we require it on our server. So we are just setting up a pretty simple Express server here, using a library to help parse JSON, setting up our static assets directory, and then we really get into the flexible stuff. So here we need to basically just grab a handle on our instance of the Fetcher plugin running for our request scoped app. Within that instance, we're going to register all of our services. So services, which we'll look at in a minute, are basically abstracted ways to make HTTP requests or to access a database. Basically, any way you can fetch data, it can support. And the nice thing about it is it provides an abstraction so you can use the same syntax, whether you're calling from the server or the client. Setting up some more boilerplate for Fetcher, and then we're going to create an Express middleware to actually enter into the Flux flow. So again, this per request, we're going to spin up this Express server, and here we are entering into the flow. So first thing we're going to do is create a context object. This is a global object that is going to be used to store all of our request scoped data, and also give you handles into the functions that you need to basically build your application. Okay, so we've got our context object. Context Fluxible is basically restricted you rather to the only functions and methods that you'll need to enable the Flux flow, and they kind of protect you from yourself a little bit by restricting access to certain methods. They have, here you can see we're grabbing what they call an action context. So they provide a different context object for actions, stores, and components, restricting each to what that element might need. So action context gives you access to functions to dispatch events, to execute other Flux actions, and to get handles on the Flux stores that are okay, and then we're basically going to take the request object, see what URL they're hitting, and try to match that to a route. We have a routes configuration file, which basically defines the path that we're hitting, the method that the path expects, and then also provides an action that's going to be run on the server once when the application is rendering this page. So here we can see execute action. It's executing the navigate action, which is matching the request's URL, figuring out which route object we're looking at, and then executing that action before we get into this call. So that's how we handle a lot of our server-side data fetching. In production, our load page actions are pretty complex. We're fetching data from a dozen different endpoints, and we're normalizing the data and doing all sorts of server logic that'll be required for the client side and for the application to function. So we'll get into that action in a second. We'll look at that. Actually, we'll look at that right now. So the action that it defined is called load homepage. So the load homepage action, again, is going to run once on the server before we send any markup down. This is basically generating the initial state of our application before we send any markup down. So in this example, we're just going to fetch some data from a a static JSON file that is in the repo here. Well, yeah, we're gonna call a service actually. So we're executing this action. We're creating a promise, which will call this fetcher service, which is an asynchronous call. We pass in the name of the service, which we'll look at in a second, and then what to call it. So inside project service, fetcher services give you a CRUD-like interface. So by default, you can define a read, create, an update, and a delete action. And then they give you, this service can be called from the server or the client, which is really nice. It allows you to use like the node request module. Basically, you can write an HTTP request once, and then the client side can use the exact same syntax. You don't have to worry about writing your own XHR request or doing any AJAX calls. You basically just call fetcher, which abstracts your XHR request and uses the same underlying service. So in our load homepage action, we can see that we're calling context service read, and we're passing in the project service. So that's calling the read function of project service. Again, each of these services are registered with our context on the server. So when you call something like context service read and you pass it a project, it knows which service you're calling. And here we are just simulating an asynchronous HTTP request. We're passing in server data, which is a bunch of JSON objects. Once that service is completed and we enter into this callback, standard JavaScript promise here will either resolve and pass in the payload or reject and we can pass back the error. We'll run we'll execute our promise, and when that's completed, we will have basically grabbed that asynchronous data and we'll dispatch an event passing that payload. So this is entering into the Flux flow here that we looked at before. So this is the action. When it's done, it's dispatching this event and passing this payload to the dispatcher. The dispatcher will basically pass this event to all the stores that may be listening to it. So our store defines a handler for this specific event. So when this event is dispatched, this store will hear it and will handle it with this function. This is Fluxible, gives you a really easy way to do all of this. Which is really nice. So this store is our project store. It initializes an empty array of projects, and when it hears this event, it basically updates your projects. So it takes the payload that's passed in with the event. In this case, it's the initial data that was fetched on the server. And it updates its internal state. So project store's state now contains all of our projects that we got from the server. Once it's done that, it does this magic line and basically emits a change. All of your components in React are set up to listen for changes from particular stores. So your React component can essentially subscribe to changes from a store. And the way that a store in Fluxible emits their change is this line. So this sends a message out to your application that something has changed in project store. And the component will hear that in a big way. So that's where the load homepage action kind of completes. It calls done, which is the callback to navigate action. So we're back on the server now. We haven't even rendered the client side yet. We're basically fetching data on the server, preparing to render our application. So now that all that's happened, we're in our callback. We can do a little error handling. And we're getting ready to basically render our application. At this point in time, we've done all the React stuff that we need to do. We've gathered all of our data, we've populated our stores, our application is ready to render itself and send down the markup. So I touched on the issue of sharing your application state from server to the client. Fluxible provides helpful functions to do that called dehydrate and rehydrate. So this line here, app.dehydrate, passing in the global context object, is going to go through all the stores and basically serialize the data and the state of your application as held by all of your stores. And we're going to stash that in a variable. So keep that. We'll eventually pass that in as a prop. The next thing we're going to do is just grab our root application component, which is defined in app.js. And then we're going to actually render our React application on the server side using this render to static markup function, which basically takes a component, renders it down to its initial HTML, passing in any props, and returns that. So HTML component is just kind of our root React component, defines our initial HTML structure. We're passing in a handle. As I mentioned, Fluxible gives you a few different contexts. In this case, we're passing in component context, which gives access to all the functions that a component in our React application would need. We're passing in a state prop, which again is the serialized state of our application from all of our stores. All of our data is serialized as JSON. And then we're going to pass in a prop called markup, which is going to be our root application component rendered. Once we have that, we're going to basically just send down the markup, send down our HTML, and the page will load. So real quick, we'll just look at what that looks like. So the page loads, this is the, oh, okay. While I have this break, I forgot to mention Wi-Fi. The network is 1551, if you guys haven't gotten on it yet. Right. And it's not back. Okay, we're back. Sorry about that. So when the server renders, this is all rendered on the server. You can see our server data. Just has these 4 projects. This is simulating a server response, and that results in this. Also, if you have questions at any point and you want to interrupt me, please feel free. Just raise your hand. Otherwise, we'll keep some time at the end for questions. But if you need me to stop, just let me know. Otherwise, I'll just keep running. So we already walked through this, but HTML component, let's look at that for a second. So this is our top-level React component. It's not extremely interesting, except that we're building our entire application in JSX, which is enough for another talk, which we're not going to get into too much today. But a few things I do want to highlight. React gives you, in JSX, this dangerously set inner HTML function, which is probably the most awesomely named thing I've ever seen in the framework. And basically, taking some of these props, what dangerously set inner HTML does is actually renders these things as if they were JavaScript. It's not doing any processing, it's just sticking them directly in and getting out of the way. So we passed in a prop called markup, which again was the server rendered version of our root application component. and that will obviously just inject the application into this div. The other thing we're doing, which is really interesting, is executing JavaScript this.props.state. So what is that again? So state, we're passing in the exposed variable, which is the serialized version of all of our stores in our application. So what we're basically doing with that line is creating a variable called app on the global window object that contains the completely serialized version of your application. So when the client side, and then we're also inserting our bundle, which we use Gulp and Browserify and Webpack on some smaller test pilot projects. Anyway, bundle.js includes all the JavaScript, including our client.js, which picks up immediately after the server sends down its data. This will run, and this is what allows the client side to basically pick up where the server left off. And React gives you a really nice way. So if you render your code on the server and then re-render client side on top of that, it's going to basically compare the DOM that exists from the server with what it expects from this React.render call. And assuming they match, which is a tangent I could go on, I won't right now. Assuming they match, it's going to keep the existing markup and just attach all of your event handlers and basically just mount its client-side application on top of the markup that was generated from the server. So the performance there is really nice. Questions?
Could you go on that tangent for a little bit?
Absolutely. So we were talking about this earlier. So as I mentioned, this client-side render call, if it encounters a DOM node that already has markup in it, it's going to basically compare the two. And if they don't match, it'll give you an invalid checksum, really helpful invalid checksum warning message, basically letting you know the DOM that it found, the markup that it found from the server wasn't what it expected, and so it was just going to re-render what it received on the client side. So you lose the benefit of that first load experience being really performant, and you lose the benefit of using server rendered data. So we were talking before, one example, we battled with this a lot up front while we were figuring things out, and one example that we dealt with was picking basically a random image from a list of images. The server would render and it would pick a random image, and then the client side would come in and pick another random image so they wouldn't match. So our solution there was to basically change that randomization to a deterministic solution there. So given some input that's consistent per the scenario, you get the same input. So we ended up using a hash function on a string and just to ensure that the image that it picked on the server was the same as the image it picked on. But React gives you really helpful error messages. That's another amazing thing about this framework. I'm sure you've probably seen a lot of them. The warnings and the errors, and they're actually quite helpful. They're not as obtuse as undefined is not a function. So at this point, the server has rendered our entire application. First load experience is really fast. Google's happy. And then client.js is coming in and basically mounting our application on top. So how we do that in Fluxible is we basically grab that serialized state of our application, which we exposed on this window app from the server, and we're giving that to a rehydrate function on Fluxible. So what that's going to do is basically take this dehydrated state, parse it out, and repopulate all of the stores that were already populated on the server. So the initial request came in, the server did a bunch of things, populated all these stores, passed the state of your application to the client, and then this is basically repopulating those stores and allowing you to pick up exactly where you left off. So when that's done, You enter into the callback, and it gives you a handle back onto your context, which again is the globally scoped thing that holds all of your instances. Then in client.js, we're basically just defining our mount node, this app node where we injected our entire application. It's grabbing the exact same root component, and again, it's rendering that component to that mount node and doing that comparison that we were just talking about. And assuming everything is happy, all it's doing here is just attaching event handlers and letting the user go on their way. So we haven't looked at this actual root node. So in app.js, we've defined our root application node as homepage. So homepage component, pretty basic. All it does is give us our main layout for the page, and then render a few child components. So project form and project list. And if we look at our actual application, it's pretty clear to see what it's doing there. So the project form component and our project list. So let's jump in to our project form. So project form, all this component is basically going to do is give us an input that allows you to add new projects to your list. So our render function, pretty basic. We have a really simple form, and we have a controlled input here. So dealing with forms and inputs with React is a little different than just dealing with the native HTML, because of the fact that React re-renders itself on every change. So inputs and forms can be one of two states in React. It can either be a controlled input or an uncontrolled input. If you are setting the value of your input, it's a controlled input, and this input element is going to have to live within the React context, so you're also going to have to give an unchanged. So initially, this input, the initial state of this component is setting value attribute to an empty string. So when the page loads, it's going to, the initial value is just going to be an empty string. Whenever the user starts typing in, on every keystroke and every change to that input, we have a handler. So that handler is basically just going to update this component's internal state with the value of that input in the text. So every time you're typing a character in, it's updating the state and reflecting that state in your input. Which is a really awesome just simplification and boiling down the entire React flow. Every time something changes, we're updating the state of the component and we're re-rendering the component. So everything stays in sync. We also have a handler on the form. So when the form is submit with this button, we're calling it to the submit form function. And submit form is just going to basically build up an object with the data that we need to actually add a project. So in a real world example, we'll be doing a lot more than this. Here we're just going to take the current state of that input when the user clicks submit and use that as the project's name, and we could handle a lot more stuff. We're going to execute an action. So again, if you think back to this Flux flow, the user's interacting with your page, and they eventually want to submit their form and create a new project. So we're going to execute an action called create project. And we're going to pass in this object called form data with the input, with the user generated input from the form. So this create project action looks like this. It looks pretty similar to the action we looked at on the server, which highlights Fetcher's awesomeness in abstracting this and allowing you to use the same syntax on the server and client. So before, when we were just grabbing the data we needed, we did context service read, which is called the read function. Here we want to actually post to the server, create a new project. So we're calling context.service.create, again, in project service. But this time we're passing in a payload, the data from the form on the client side. So if we go back and look at project service, the create function, you can imagine this would be doing a post, an HTTP post to some server to actually create this project, but here we're just going to add it to the server data array in memory. And then simulate that asynchronousness and then set timeout. And once that's done, we enter into this callback. We can do some error handling there. And eventually we're going to basically dispatch an event that the create project action has succeeded, and we're going to pass in some new data. In this case, our server returns the entire list of projects, including the one we just added. So it just adds that to server data, passes back the new list, everything we had before, plus the one we just added. And we're going to basically dispatch the exact same event that we dispatched earlier on initial page load. And we're just passing in an updated list of projects now. So the same exact flow we looked at before is going to happen again. So we're dispatching this event, the project store. Here's that event, updates its internal state. So now project store's internal state is going to have the projects property that contains the newly added project in addition to the ones we fetched earlier from the server. It's going to emit a change, and our component is going to hear that and re-render itself just like it did before. We haven't looked at it yet, but I hope this is really illustrating the beauty of isomorphic application. It's the same flow, and it really simplifies things a lot. So, as I mentioned, the component will hear that change emitted. So this is that project list component. We haven't looked at it yet. Fluxible allows you to set this static attribute on your component, and it lets you define stores to be listening to. So any stores you put in this list, whenever one of those stores fires off a change event, this component will hear it and it will trigger an on change. So Fluxible, again, gives you the store listeners list, and whenever a store in that store listeners fires off that emit change event, it's going to handle it with this on change function. They also allow you to create different handlers. By default, the handler for a store's change is this onChange function, but you can define your own. So a change in project store might be handled with onChange, and a change in application store might be handled with a different function here. So a lot of flexibility is my point. And what happens here? So let's look at this. So when this component initially renders from the server, the initial state for the component, which you're probably familiar with, is going to just grab all of your projects from your store. Return of projects property that has all of your projects. When this component hears a change from project store and it handles it on change, all we want to do is update the internal state of our component with whatever change triggered that update. So if we think back to our flux diagram, an action happened. In this case, it was submitting the form on the client side. That action dispatched and passed along the payload from the user's form. It updates the store updates its own state, emits a change event, and fires off its change event. This component hears it and updates its internal state with the current list of projects in your application. And as soon as it fires off this update to the internal state, based on, this is how React works, when a state changes, it re-renders. So when you call this .set state, it's going to fire off an update to this render function. And when it's rendering, all it's doing is basically taking the list of projects that are received from your project store, mapping over them, and basically outputting a project component for each one, passing in the data for that project. And the project component is really simple, basically just creating that grid element picture in the project. That was a lot, yes, thank you. Please, question.
Would you have to add a different action to account for optimistic rendering? Because callback was inside of a set timeout or pop pacing.
Yes, great question. This flow really lends itself well to optimistic rendering. As soon as, so for example, in create project here, and this is a pattern you'll end up seeing a lot. You might, before you actually enter into your asynchronous thing, you might dispatch an event called create project start, if I can type. And then you can handle that in your store separately, where you can store the payload in some queue, basically. Add it, re-render your application, and then whenever this comes back, you can pass in a success or failure message and either just move that newly sort of pseudo creation into reality and move it into your store, or you can delete it. So being able to dispatch different events at different points in your asynchronous flow really allows you to render things optimistically like that. And, yeah, great question. We do the same kind of thing with with spinners. As soon as an action starts, you can fire off like a start action, handle that, and then when your asynchronous operation completes, you fire off a finish action, and you can stop spinning, or you basically would end up setting state is loaded to true or false. So you can really manage these asynchronous operations as if they are. And they are just static points in time. Your state is always immutable. React doesn't allow you to modify your state directly, so you can always trust what you're getting as state, and when state updates, you'll basically re-render. So yeah, it lends itself really well to that optimistic time. So let's see it work. Ooh. That was exciting. Yeah. That pretty much concludes the code. I think we've walked through pretty much all of it. So again, to kind of encapsulate all of it, Fluxible allows you to really easily kind of render your application on the server, scope data per request, so there's no leaky data, and then it allows you to share your state from the server to the client. You send down your server rendered markup. The client picks up where you left off. It repopulates all of its stores, re-renders itself, pseudo re-renders, basically just attaching handlers, and then letting the user go on its way. And then as the user interacts with your site, it's just the same cycle that the server initially went through. Any other questions? Yeah, way in the back. Okay.
Have you ever had any problems with like if users turn off their JavaScript, and does it still work without it?
Great question. Let's try it. So if we disable JavaScript and re-render our page, the network is not good, but as you can see, it's still rendering. So that is another huge benefit of our isomorphic architecture. So if a user is on a really slow connection or doesn't have access to JavaScript, we're still sending down a really rich experience on that initial page load from the server.
What else can you do with the site besides loading it?
I mean, not a lot. What can you do on the internet without JavaScript, really?
So it loads, okay.
I mean, yeah, it's a completely static representation, just pure HTML, but it still did a lot of really cool stuff to generate that static HTML.
It's a lot better than no page at all.
Yeah, exactly. There's another presentation on kind of isomorphic architecture I saw recently, and it had all these screenshots of massive websites that we all go to pretty much every day, trying to render them without JavaScript or on like an edge connection, and there's a lot of blank screens. So the nice thing here is at least you send down a pretty rich experience regardless from the server. Second from the 90s. Yes.
How well does this lend itself to being used in a small part of the page as opposed to taking over the total content?
Great question. Yes, the fluxible and kind of the flux flow may end up being overkill if you're doing something really small and really isolated, or if you're doing a relatively static page. There's a lot of kind of boilerplate process that goes along with it. It really only starts giving you the real benefit when you get into really complex applications and interactive pages.
So then if you have a site that had a large portion of your screen real estate was fairly simplistic, and then you had one very complicated inspector panel, would this be applicable?
You certainly could. So another approach, in this example, we were rendering the entire page, including our HTML tags, as components in React. Another approach is, since we're rendering server-side, you can really you can build a completely static page and just insert the server-rendered portion of your application into that domain. So, I mean, really here we're rendering the static markup, so we're not making use of any of the React magic on the stuff that's in the HTML component, only once we get into the actual application component. So you could build your page in handlebars and just kind of mount your React application into a specific node and still render it in the same way. And Fluxible library, I think, would still provide a lot of benefit for that one specific component. And you may choose to just not use Flux for the rest of the page.
What if you're doing the same case, but you had like 10 different widgets on the page instead of just one?
I mean, I would think that you would probably, if you have 10 really complex interactive widgets on the page, you probably want to just do the whole page with this process. Otherwise, maybe find some parent node and just mount your React application in that parent node that encapsulates all of your high complexity functionality. Yes.
How do you handle isomorphism with regards to routing? Like, you have complex routes that you want to use through the API and
Yeah.
all that kind of stuff, but you don't want to really go up for an express server or whatever.
Totally. Awesome question. I didn't get into this example, but one of the other small core libraries that Fluxible encapsulates is called Router, R-O-U-T-R. Out of the box, Router supports navigate. It initially tries to use the history API and use push state if you set it up that way, and basically just gracefully degrades itself all the way down to doing full page reloads using the same exact syntax. So that navigate action that I talked about comes with another module that Yahoo provides called Flux Router Component. I think they're actually in the process of kind of combining consolidating a lot of these things, because right now there's like 6 packages that you need if you want to run the whole flexible library. But this navigate action will start trying to use history API for completely client-side. So yeah, I mean, you can really have the best of both worlds here. You render a full experience from the server, but then if you code it up that way, you can have a single page app experience from the point that the client side picks up. It's really powerful. Yes?
So I noticed with your little demonstration of the turning up JavaScript and then reloading the page, you still have the new items that you add.
Yeah.
In the previous step when you had JavaScript, but I don't see anything. I'm missing something about where did this get to the back end or what was going on there.
Yeah.
The magic is between running stuff on the server and actually making requests.
Totally. So they persist between page reloads because they're stored in that array in Node's memory. So if you kill your server and restart your server, you won't have those objects anymore. But when we're creating our new projects, we're literally adding it to this server data object, which exists in Node's memory. And so between page reloads, it doesn't need JavaScript actually, because when the server side load page action, again, so the action that's defined in your route, this load home page action, is all it's doing is really reading from project service. So we added a project client side that added it to this project's database in Node memory. And then we reloaded the page. It doesn't need JavaScript to access the current state of the project store, which already has these newly created projects in its internal state.
Okay, so there's some sort of communication that was going on between the client and the server, right?
We added the project when we still had JavaScript on.
Yeah.
Yeah. So.
Yeah. So there's some sort of communication there.
Mm-hmm.
And I guess I'm missing are there routes? Is there RESTful endpoints, or what's the
project server
magic that's going on there that I seem to be missing?
Absolutely. So the create project action is the one that gets executed when you submit the form. And so create project action is basically calling this create function in your project service. So project service .create is adding that project to server data. Server data is just an object in Node memory. So when you reload the page, on every page reload, the load page action is calling the read function, which is just giving you back a representation of server data. So when you add the project to server data, the next time it calls this read function, it's going to give you that newly added project as well. Does that answer your question?
Not at all.
Not at all.
It sounds like it's asking when does it cross from the client to the server?
Yeah.
That the code's executing. At what point is there something that leaves the client and the server is now making these changes in Node? Is that correct?
Yes.
Okay, I guess,
yeah. I don't see anything else like, oh, there's no project endpoint on a traditional looking API,
right.
just spelunking around.
So,
code.
yeah, no, I mean, you're absolutely right. So
I don't see
Fetcher,
any configuration for that or anything like that, so, magic.
it is magic. This action, again, so Fetcher basically abstracts all of these messages, or these functions. So anywhere in your code, you can call one of these server-only functions. So your services only live on the server. And so the client side can basically just call this abstracted create function, which does, on the server, handle the payload that it receives. So the API that you're looking for is really just this function call right here. So this line is just calling this server-side function and passing in this payload as a thing.
So it's building up an
basically,
AJAX
there's a
request.
singular endpoint, and inside of the DAP, it determines what to do the routing rather than pulling out a URL.
I'm sorry, now we're talking about routing or?
Yeah, so to identify, where typically we'd identify the service or the action based on something in the URL. It sounds like you're saying a singular endpoint, and something in the content of the data identifies where in the server code to then start back up.
Perhaps open up the network tab and then Chrome and add an item and see what exactly gets posted to the server.
Sure, we could do that. But I don't know if I mentioned this passing in this string project service is actually the name of this this service. So that's how it knows what function to call. If that helps. When we're in create projects and we're calling the create function of this service, so project service. Yeah. So. Re-enable JavaScript. And you wanted to see
Just what does it post to the server when you add it?
It looks like Fetcher has just
Yeah.
a slash API route where it accepts these post requests. So it looks like Fetcher is doing all this magically for us.
Yeah, by default. So that is the abstraction that Fetcher provides. Is it allows when the client side calls something like this, what it's really doing is making if it's coming from the client side, it's making an XHR request to a endpoint that you can define. By default, I probably should have left it there. By default, it is /API. And it passes in the request parameters that you define when you're creating your context. So XHR context. When you're creating your Fetcher plugin instance, you can pass in, I believe it's XHR packed, and you can put in any string here, so custom endpoint. So then when your client side actually calls one of these service functions, it's gonna do an XHR request to this endpoint, which Fetcher can handle and still run the server side service.
So then does that mean that the result is basically event name plus data, right? So does that mean that as long as you listen in both places, you could have your API backend could actually be in something different? And as long as Fetcher on the server side and on the client side both listen and both symmetrically update their state, you could use a legacy backend in the API as long as it responds with the right kind of string and the right data.
Sorry, so having a separate backend
Yeah, so
based on whether you're calling it on the server side or the client side.
yeah, so if I have some legacy thing, could I put it at my legacy and actually have Fetcher listen to that event as it comes through and still keep the server in sync with the client, but the result of the event is coming from something totally independent?
So at the point where it's coming into Fetcher, it's the benefit that Fetcher provides is really allowing you to write one service call and be able to call that from server side or client side. So whether it's accessing some legacy database or hitting some HTTP request, that it doesn't really matter. Fetcher, if they're not opinionated about where you're getting the data from, all they're concerned with is allowing you to get that data and then use that same syntax to get data, whether you're calling on the server or on the client.
But Fetcher would still need to be on the server would still need to be in the mix, right? I couldn't directly proxy to something else.
Right, okay, yes, yeah. Good question. So, but inside these really generic re-CRUD functions that Fetcher provides, you can do whatever you want, and then the client can just call it in an abstract way. It's use the same syntax. That was a lot. I feel like I've been talking a lot. And I think it's about 8:15. Does anyone have any other questions? If not, oh, there's one way in the back.
There was just a question in the forums, which is why pages were put in their own directory versus in the components directory.
Good question. That is a convention that we have adopted at Porch. It kind of touches on the notion of having a kind of a container component, which is something that's being talked about a lot in the React community right now, and that's really separating the act of grabbing state from stores and handling your component lifecycle methods, separating that from the actual rendering of your component. So along those same lines, we have decided basically to keep our root level application components separate from our child components that may be reused on 5 different pages. It's really a maintenance thing. As our application has been growing, and in these last 6 months, we have probably 100 components in our repo now, and we have 10 different pages and container components. So as far as React is concerned, there's really no difference between this homepage component and this project list component. But for our convention, this homepage component will be used once. It's a page. Whereas the child components may be reused on lots of different pages. So, yeah. All right. Up. Yeah.
Yeah, one more from the Clueless Business Guy. Everybody's following along with React, and so has our team, but we don't have any experience with it. Any tips for how you tackle that? Because we're ready to pretty much whole hog rip out what we have and go React and SVA, but it seems like there's not a ton of experience around that have been through these projects before.
Yeah, I mean, that's, I think that's something we're all dealing with. And it's exciting too, I haven't personally been as invested in like the early stages of a framework, and there's a new tutorial and a new blog article popping up about React every day, and the patterns that are used on the React side I feel like are pretty well baked out at this point. And I'll share some of my favorite resources on the Meetup page tomorrow, as well as sharing a link to this repo. And, anyway, the Flux side of things is really still kind of coming into its own. Facebook intentionally left it pretty vague and didn't share exact patterns. It was more of a high-level kind of conceptual architecture pattern, and so as a result of that, there have been a ton of different implementations and different interpretations, and so on that path, you're kind of on your own. There's a lot of good resources out there, and again, I'll share some. We went with the Fluxible implementation. At the time, it was pretty much, it was one of the more mature. When we first started developing with React and Flux back in October, I think there were maybe 3 or 4 Flux libraries. There was Fluxible, McFly, and Fluxor, and Reflux. I think that was it. And now there's probably 100 little Flux implementations. So the community and it's getting a little bit fragmented. Facebook says they're coming out with what they call Relay, which is like the next step in the Flux pattern, and that should, they say it's going to simplify a lot of these things and kind of converge on one way of doing things. But to answer your question, there's some great tutorials on scotch.io. That's some good ones, and I'll share some more links. But we're going to be having, I think, a lot more of these Seattle React JS meetups. This group will be continuing at least monthly, and we hope to host some more here at Porch, and I know some other places will host some. And, yeah, if you have any specific questions, you can ask us. We have a shameless plug for our Twitter account, which we just started. So Porch Dev on Twitter. Feel free to follow us and also ask questions, and we'll be sharing lots of interesting updates. As time goes on.
Are there any alternatives to this isomorphic rendering besides flexible? Maybe something not quite so heavy-handed?
Yeah, there's a lot of different ways to do it. I know our Flexible's approach is basically to create one global singleton and instantiate each of the stores per request. There are some other approaches. I know SoundCloud, for example, is doing an isomorphic architecture where they're using all singletons across the board. I don't have a recommendation for like a different framework that's specifically made for isomorphic applications. There are, yeah, I mean, there's a lot of, you could roll your own and, well, I don't know. Sorry, that's not a great answer. I don't have another recommendation. I think Flexible is pretty awesome. And it's pretty heavy, but they're iterating really fast, and they're actively working on it. And even as of today, I think they've changed around how they're handling some of the context. So if you want to refactor your code base every couple of weeks.
Just following on to that, I found one really good Flux implementation is Reflux that's more lightweight if you're looking to kind of play around with it.